Students, today we'll study simple microscope. Simple microscope or a magnifying glass is a convex lens of short wavelength. Now come to principle of simple microscope. When an object AB is placed between the focus and optical center of a convex lens, a virtual, erect and magnified image is formed on the same side of the lens as the object. Since a normal eye can see an object clearly at the least distance of distinct vision, it is 25 centimeter and is represented by D. The position of the lens is so adjusted that the final image is formed at the distance D from the lens. Now see the ray diagram. Here we have considered one convex lens of short focal length. See O be the optical center, F focus. When an object AB is an object is placed between optical center and focus, a virtual, erect and highly magnified image A dash B dash. Here you see A dash B dash is an image. It is virtual, erect and highly magnified image when object AB is placed between optical center and focus. See distance, object distance. Here we have considered x. F be the, we know that f, small f be the focal length of the lens, and D is least distance of distinct vision. It is equal to 25 centimeter. Now see, AB is object. It is object. A dash B dash is image. Angle A dash O B dash. This angle A dash O B dash is represented by beta. Angle A double dash, here you see A double dash O B dash, it is an smaller angle, is represented by alpha. We can calculate magnifying power. We know that magnifying power is a ratio of angle subtended by the image at least distance of distinct vision to angle subtended by the object at least distance of distinct vision. Mathematically we can write magnifying power is equal to angle subtended by the image at D. D is least distance of distinct vision divided by angle subtended by the object at D. This magnifying power is represented by small m, so that we can write m is equal to beta upon alpha, or we can write tan beta upon tan alpha, since alpha and beta are small angles. Now from the figure, from this ray diagram, we can write tan beta is equal to AB upon OB, and for tan alpha we can write A double dash B dash upon OB dash. or AB upon OB for tan beta divided by, for tan alpha we can write AB upon OB dash. Since AB, this AB is equal to A dash double dash B dash. For A double dash B dash we can write AB. Now, after simplification of this, after simplifying, we can write OB dash upon OB. It is magnifying power. Now, OB dash, you see this distance is represented by D. So, for OB dash, we can write D, and OB is equal to OB is equal to X. Using sign convention, we can write OB dash minus D and OB minus X. So, magnifying power M is equal to minus D upon minus X. After simplification, we can write M is equal to D upon X. Let F be the focal length of the lens. Focal length of the lens, as the image is formed at D, as the image A dash B dash is formed at D, and this D is image distance, so we can write V is equal to minus D using sign convention. Now, using lens formula, we know lens formula is 1 upon V minus 1 upon U is equal to 1 upon F. Now, substituting the values, we can write 1 upon minus D minus 1 upon minus X is equal to 1 upon F. Here we have used sign convention. After simplification, we get 1 upon X, because minus minus will become plus. So 1 upon X minus 1 upon D is equal to 1 upon F, or 1 upon X is equal to 1 upon F plus 1 upon D. Multiplying both sides by D, we get D upon X is equal to D upon F plus D upon D will be 1, so that we can write M is equal to 1 plus D upon F. Why M? See, we have magnifying power M is equal to D upon X. So, for this D upon X, we can write M. Now, we have M, magnifying power of simple microscope. M is equal to 1 plus D upon F. Thus, the shorter the focal length of the lens, the greater is the magnifying power.